Hello Year 12 and welcome to the fifth video here for our second topic. We're looking at direct linear variation, and we can think of these as being very similar to the linear functions we looked at in the last exercise, but without a y-intercept. So in many ways they're a bit simpler, just with some different language. Now linear is treated the same. We still mean a straight line graph here. When we talk about direct linear variation, we sometimes also use the word proportional. So if I say something is directly proportional to something else, okay, then that's an example of direct linear variation. Instead of writing these as y equals mx plus b, we can simply write these as y equals kx. So k is our constant of proportionality, is just the same as our gradient. Remember I said at the beginning that these don't have a y-intercept of 0, so I don't need that plus b on the end. So the big thing is recognizing these from a question. Directly proportional is usually the key phrase, and we start by writing y equals kx. Then we substitute a pair of coordinates, an x and a y, into that. We solve that equation for k, and then I rewrite the equation substituting that value of k in, but leaving x and y as pronumerals. I'll show you how that works. Here we have the distance that can be travelled as directly proportional to the volume of petrol in the car. And I have an example that I can go 465 kilometres in 48 litres. So D is directly proportional to V. So we say that D equals KV. There we go. Now I'm going to substitute in for D 465. 465 is the unknown k times 48. Solving that, I get k equals 465 over 48. Therefore k equals, and I'm going to need a calculator, turn it on, 465 divided by 48 equals 9.6875. It's not so neat. Oh, my pen. 9.6875. Not done yet. I've found k, but I need to rewrite that as saying, oops, sorry, people. That, therefore, D equals 9.6875 V. Okay, so I've got a formula now, really, to calculate how far I can drive for various amounts of fuel. And what do you know? That's what I'm being asked to do next. So now I use this formula I've created, right, that we have referred to as a variation equation. So how far can I go? Well, my distance equals 9.6875. 6875 times 56 this time. Right, calculator comes out, and I've still got that 9.6875 on the screen, so I'm just going to go times 56, and I get 542 and a half. 2.5. Now does that make sense? If we compare that to the previous one, 48 litres, so a little bit less petrol, we went 465 kilometres, right? A bit less petrol, didn't travel quite as far. A bit more petrol, we travelled a little bit further. Right. And finally, how many litres of petrol are required to travel a distance of 200 kilometres? We're going to have to do something else here, or ever so slightly different. This time I don't have a... oh no, it's much the same. Oh yeah, that's right. No, this time I don't have a volume to substitute, but I do have a distance. So I'm going to say this time that 200 equals 9.6875 times the unknown volume. Rearranging that, my volume is 200 divided by 9.6875. Means my volume is Right, out comes the calculator. 200 divided by 9.6875 equals 20, what do we want? One decimal place, 20.6 litres. There we go. Rightio, so that is direct linear variation. We write an equation, y equals kx, substitute an x and a y, or a dependent and independent. We substitute values in to find the constant of proportionality. We find the value of k, and that gives us really a very simple equation for solving some other problems. Okay. I hope that worked out. I'm sorry for the technical difficulties we went along. Same thing I always say, if you've got any questions, jot them down so you don't forget, and make sure you ask your teacher. Thanks very much.